Hello guys, welcome back to this video series of data analytics with R. In this video we will talk about matrices. How can we create a matrix in R? So there are two ways to create a matrix in R. We'll see that. Then we will see how does R deal with incomplete data while creating the matrix. We'll see what is this. We can assign row names and column names to the matrix. How can we convert the matrix dimension? That is what we are going to see. Transpose, and we'll see some libraries as well. Okay, so this is the uh, topics for these are the topics for this video. Let's get started. So creating a matrix is very easy. You just type matrix. What elements do you want in this matrix? So just one for this case, and this is the size of the matrix. Okay, so when I do this, you can see uh, there's only one, and the size of the matrix is 2 cross 2. Okay, you could also do something like this. So say 1 to 4. So this is 1 3 2 4. I mean, so over here R always goes column wise. So 1 2 3 4. Okay, or else you could also use a C operator to define your old matrix. So let's say 2 5 7 9. 2 5 7 9. Okay, so this is first way where you can manually create a matrix. The other way is you create two vectors. Say x is a vector like this, y is a vector like this. Okay, and then you say row bind. Okay, so this is row bind. R bind means row bind. So these two will become rows. This is the first row and second row. And let's see. Okay, so x is one row, y is the other row. This is what will happen. Or else what you can do is, say you have x and y, you can do column bind. So in column bind, this will become a column, this will become the second column. So column, column. Okay, these are like the three ways by which you can make a matrix in R. Now, what happens if you have incomplete data? That is, so over here you can see this is a two element vector. This is a one element vector. This is a two element vector. This is a two element vector. So you can see, I mean, when you have rows, all the rows of a matrix should be of the same size, right? You cannot have two and then one and then two, right? So here that is the case. Here you have two rows, two elements in a row, only one element, two element, two elements. So what will happen? We'll see. Okay, and let me just run this. Okay, so over here you can see if there was only one element, what it does is it repeats the same element again, repeating the same element again. So now this is complete. Okay, this R does automatically. You don't have to write any command for that. Okay, so again, then it also gives you a message. Okay, this message. Okay, so if there is only one element, it will not even give you a message. Okay, so just make sure whatever you're doing is right, because R will not always give you an error like other languages. Okay, MATLAB or Python may give you an error if something like this happens, but R won't. Okay, now here you can see that there are three elements and this is four elements. Okay, so what R did was it repeated this element, that is as we did in addition. So this is 71, 73, 65, and then again it repeats 71. So it is trying to match the bigger element list or the bigger element vector by repeating the numbers. So if there would have been 5 numbers over here, say 78, so 73 came again. I mean 71, 73. So it will repeat according cyclically according to match the length of the larger vector. Okay. Similarly, here there is 4 element and there is 3 element. So it repeats. 172 is repeated. Okay. This gives you a warning, but the first one, if there is only one element, it won't even give you a warning. Okay, so it's very important to know what you're doing. Okay, then here you can assign row names and column names. Say you want to name every column over here, every column and row. So say you create a matrix, say 1 to 6, and you can also define it like this: n row, that is number of rows that you want is 2. That's it. So 1 2 3 4 5 6, and the number of rows that you want is 2. Then you can say, so if x is what you have defined, so row names of x, this is a function. So row names of x, you can define it as r1 r2. You have used the c function over here, and column names of x is say c1 c2 c3. Okay, let me just, yeah. So this is 1 to 6, 1 2 3 4 5 6, and I just want 2 rows. You can also change this to 3 rows, but then you'll have to change this as well. Yep. Now you've got 3 rows and 2 columns. Okay, so accordingly you can actually create a name for every row. So that depends on what data you have. So say if you have some data that has something, I mean the marks of the student, so you can name every column so that it is easier. Okay, now how to access the elements of a matrix. So say you want to access this one. So it's simple. You take the name x, and this is 1 comma 1, so you get 1. So if you want the whole row, what you do is you put the row number and leave the column position blank. So this will give you the whole row 1 4. So 1 4 is over here. If you need a column, leave the row position blank and tell which column do you want. I want the first column. Then that will give you the first column 1 2 3. Okay, so like this you can access the elements of a matrix. Okay, here let us see some logical operators, because you will use that. So you have less than operator, you have greater than operator, you have less than equal to operator, you have greater than equal to operator, and you have equal to operator. Let us see where we can use these operators. Okay, so say I want to filter this matrix according to some operation. So say I want all the elements of x that are less than 3. Okay, I just want all the elements of x that are less than 3, and you get them. So there is only 1 and 2 which is less than 3. Now if I put an equal to over here, 3 will also be there. So all the elements of x that are less than 3, 1 2 3. Let me make a different matrix so that it becomes easier. This is very simple. So let x is equal to c. Oops, I want a matrix, right? Matrix C. Say 4 7 2 8 10 3. Okay, and I want 2 rows. Let me first print x. Okay, so this is how x looks like, and I have said x, all the x values less than or equal to 3. So I got 2 and 3. So just 2 and 3 are less than 3, hence they are over here. So like this you can also filter the elements. Say you want only 3, you'll get only 3. So if suppose you have a value that is not there over here, like say 1, so it will give you nothing because there is no value. So double equal to means is x equal to or equal to 1. Okay, so that means, I mean, is there any value of x that is equal to 1? Only 1 equal to will actually assign one value to x, right? But that is not what you want. You don't want to assign 1 to x. Instead you want to check if there is any 1 in x. Okay, so this is how you can actually filter the elements of the matrix according to some logical operators. Okay. Next, let us see how can we convert the matrix dimension. So say X is this and you want to make it a vector. So it is a matrix now. You can just type as dot vector and you get the vector notation of this. So remember, it always goes column wise. So 4, 7, 2, 8, 10, 3, 4, 7, 2, 8, 10, 3. Or say you have X as a vector. Okay, so this is 1, 2, 3, 4, 5, 6, and you can change the vector to a matrix like this. So say you have this is a function dimension of X, and you can specify what dimension of X you want. So over here it's say 3, 2. So what happens is this vector, this 1, 2, 3, 4, 5, 6 will become a matrix of 3 rows and 2 columns. Okay, let us see this. So this becomes 1, 2, 3, 4, 5, 6 column wise. Okay, this is 3 rows and 2 columns. If you put 2 and 3 over here, you will get 2 rows and 3 columns. So you can change the dimension of X accordingly. And you can also, view the dimension. If you just put dimension of X, it will tell you what is the dimension. So 2, 3 is the dimension of X. Okay, then is matrix. So this is a function is dot matrix X. If X is a matrix, it will say true, else it will say false. Okay, so if you put something like this, so this is a vector and not a matrix, hence it says false. Okay, so this is a function that will tell you is it a matrix or not. Okay, so that was to convert a matrix dimension. You use the dim operator. This can convert the given matrix into any matrix you want, any size that you want, and here you can convert it as vector. Okay, what else? Okay, just T of X will give you the transpose. So this was the matrix earlier. You do T of X, you'll get the transpose. Very simple. Now you can also use some libraries. So like there is a library called mass. Okay, so now there's this function from this library, fractions. So this, if you just execute without loading the library, it will say could not find function. So you will first have to load the library. So this fractions comes from the mass library. So you'll have to load the library and then you'll have to run. So here you can see what fractions does is it will do 1 upon 1 to 10. So this gives you 1, 1 by 2, 1 by 3, 1 by 4 up till 10. So this 10 is in, these numbers come in the denominator. Okay, you can also do 2 into fractions. So that will multiply everything by 2. Okay, so in case if you don't have this library, so it's not necessary for you to have all the libraries. What you can do is there's a command install dot packages and say mass. So for me it gives me a warning message that package mass is already in use. So I have already downloaded this particular package and I have this package, so it will not be installed. But say if in your case you don't have a particular package, you can just type this command and you can get that package. Okay, so that's all for this video. Here we saw about matrix and matrix dimensions. In the next video we'll go to data frame. This is a very important topic. See you there. Thank you so much for watching. Thank you.